Classes are simply blueprints for objects we'll create. For example, let's say we want to create houses. We simply need a blueprint on how to build them. Remember, the class, or the blueprint, is not actually the object. It's simply what we're going to use to build objects. Once we have our class or our blueprint, we can create an infinite number of objects. For example, from our house class, we could build a red house, a yellow house, a green house, or any color we really wanted. Let's talk about classes. We've touched on them before, but we haven't really deep dived into them. So, at its fundamental concept, what is a class? Well, it's a blueprint that we can use to create objects. Notice the wording there. It is a blueprint. It's not the actual object. So I have this graphic here. It's a house blueprint, not the actual house. So the class itself is just simply a text file that we write code into, and we can put different functions and properties and things like that in there. And from that, we can do really cool things. We can create any number of houses. Let's take a look at this little example here. Let's say we wanted to make a rectangle. You notice how this rectangle has different properties. So for example, I can change the text, the color, all the size, all this fun stuff, but it's a shape. So the class here would be a concept of a shape. We can make a circle, we can make a diamond, we can make millions and millions of different types of shapes. We could say, this one, we don't like that red. We want this one yellow. We want this one green, and so on and so forth. And we could change all these properties however we wanted to. We could even say we want this one bigger. We want this one smaller, that kind of thing. But at its core, these are still all shapes. And if you click on them and you watch over here, you notice the properties change, but these little boxes don't, because they're all the same class. Now, if that's not abundantly clear, I like to use what I call the donut example. Every culture, every language all across the world has something like this. It's called a donut. You may call it something different, but it's the same basic concept. It's just fried bread with sugar. These things are delicious, but here the class would be the concept of a donut. You can see there's all different styles and types of donuts, but at the same core, they're all donuts. So when you create an instance of an object, you're actually creating the donut, or the class would be the recipe for the donut. So let's take a little deeper dive here. I'm going to wipe all this stuff out, and let's just make a box. And let's just take this box and say, okay, this is our blueprint. From this, we can take this blueprint and make copies of this out in memory. And I don't want to really call them copies because they're not. They're actual full-fledged objects. And we can change their properties and say, this one's red. This one's going to be green. We could make, this one a little bit bigger, and we can make this one a little bit taller. We can do things like this, move them around however we want them, and do things like that. Notice how they're all rectangles from this blueprint, but we can create instances of them and change their properties. And when we're done with them, either C++ will delete it for us, or we will go out and delete it ourselves. You saw that when I used the new keyword and we created a new Q object, and then later we called delete, and we did literally this. Delete, gone. It gets a little more complex than that as well. So for example, you can take this humble little blueprint here, our class, and you can inherit it. And what do I mean by that? So let's say we have this class. We make another class and we inherit from it, but we're going to add some special feature. So for example, I'll just add this little oval in the center here. And you can have other things as well. So let's say we have this diamond here, and let's give this some special color. And let's add a cloud. Why not? Just kind of grasping for what I should add here at this point. And let's give this a completely different color altogether. So we have a diamond, we have this complex shape, and then we have a cloud. And these are three distinct different classes. We could do what's called multiple inheritance, where we take all of these and combine them down into one class, meaning it would have the properties of all of them combined. That's kind of crazy. So the point I'm making here is that when we talk about classes, it's not really a simple conversation, but we can really distill it down to a class is a blueprint for an object we're going to create. We can create any number of classes or blueprints, and we can even take parts, or I should say all of them, and put them into another class. Now I say parts or all because there is the concept of what's called an interface, which is meant to be an individual part that's used in a bigger object. But classes, when you get into inheritance, you can inherit one or multiple classes. That has a whole host of problems with it right then and there. At its foundation, most of the classes in Qt inherit QObject. We've talked about that before. Let's dive in and let's take a look at classes. So what are we talking about? This is the introduction to classes. Why? Because we want to learn to create objects from blueprints. Notice how I said we are going to create objects from the blueprints being classes. Okay, so first things first, we need to actually create our class or our blueprint. Now, this is going to be a little bit different if you're in QMake, but we're in CMake. The steps are pretty much the same, but you got to look for the project name here and then right click and then add new. And then from here, you're going to go to C/C++ with a C++ class. You'll see source and header file. I explain what these are in just a second, but just trust me on this. Click on class and choose. You're going to get this define class dialog. This is actually very, very simple. You're just going to give it a name. This is simply the name of our blueprint. I'm going to say animal. Base class goes into a concept we're going to cover called inheritance, where we're going to inherit the properties of another class, or basically we're going to take another blueprint and add our own custom stuff to it. I'm going to choose QObject. And you notice automatically it checks this include QObject and add QObject. I'm going to explain what both of those are in a minute, but right now just take it on a giant leap of faith. It's going to create two files, a header and a source, and then this is the path it's going to create it on. Hit next, and hit finish. Now, this is something you're going to see if you're on CMake, and this is with the current version of Qt Creator. If you have a newer version than what I'm using, this may do it automatically, but basically what it's saying is files are not automatically added to the CMake list.txt. Do you want to copy them? You can say yes or no, it doesn't really matter. I'm just going to say yes. It's going to automatically open up this CMake list.txt. Just in case you click no, basically it's going to dump you into this file, which if you're just curious what it is, it's animal.cpp. Notice how it's not in our project. We need to double click this CMake list. And this is where it gets really scary looking, but basically we need to go down to the add executable, and under here we need to manually add this. If it's in the same directory, it should automatically find it. And we're going to add both of those files. Go ahead and hit save, and you should see this little thing pop up down here parsing your file. If you mistype something, you're going to see something like this. Let's just add in some gibberish. And it's going to say, oh, red bar, couldn't find it, and it's going to tell you could not find this file. And then you just simply go in and fix it. Once you fixed it, just hit save, and it will rescan and configure and all that. Point being, you should see headers and sources. You should have animal H and animal CPP. So what are all these files? This is the confusing bit about C++. They really don't explain too well in most schools. So you have what's called a header file. This is what's going to be included. See where it says include QObject? Somewhere out there, there is a file named QObject.h, and we're actually including that. Same thing with our main. We've been doing this over and over again where we do an include Q core application. Somewhere out in the world is a .h. We're actually including that header file. So this is the actual blueprint part. This is where we say what we're going to do. The source or implementation file, commonly referred to as a .cpp, is, well, where we make the code that's going to actually work. There's a heated debate among programmers. Some people will not even use a CPP and they'll do everything right in the header file. Now, because of that, I want to sidetrack just for a moment. In newer versions of C++, there's a concept of a module, and I'm going to flip over here. This gentleman has a really great group that's all about C++. You notice this is C++ 20. Now, in case you're curious, it's Modern's C++. You can actually join them out on Facebook. I'm in that group, pretty great group of people, but module's a little bit different, and this is new for C++ 20, where it kind of converts that and it uses a module or a single file instead of two of them. So before you rush out and really dive in, want to do everything in modules, you'll just understand that, well, most of the world for decades has used headers and implementation files. So I don't want there to be any confusion. We are going to use headers and implementation files, but just in case somebody out there brings up the topic of modules, this is what they're talking about, where it kind of takes all that, smashes it into one file. There's a lot more to it, but essentially you have to use C++ 20. If you're ever curious what version you're using, it's in your CMake list, and it is this CMake CXX standard, and I'm on 11. Now, to change this, you could very easily say you want to do 17 or 20, not 290, that'd be weird, but 20, whatever you want to use. Out of the box, Qt Creator's using 11. That may be different depending on your implementation and your setup and everything. So now that we've gotten all that out of the way, let's look at our blueprint here. There's some things we need to understand right off the bat here. So this right here, if and def animal underscore h and then define. What are we saying here? This is a preprocessor directive where we're telling, remember from the compilation process we talked about, we have to tell the compiler and the system what we want to do before we actually compile it. Those are called preprocessor directives. And this is saying if not defined, and it's abbreviated to if and def, and then some name. It looks big and scary, but we're basically saying if we haven't talked about this before, we're going to talk about it now. And then we're going to define it, meaning we're going to tell the world this is what it is. And then way at the bottom, we have this and if. So we have an if and end if. We understand the if statement and flow control, and this is very similar. We're telling the preprocessor, hey, this is something we're going to define. If we've already defined it, don't define it again. That gets into a little bit more of advanced C++, but I want you to understand what these actually mean. We're defining something. Now, we're going to go ahead and include QObject because QObject is the base class of, well, pretty much everything in Qt. Here is the class definition right here, and it looks eerily similar to a structure. I mean, I would dare say it is almost identical to a structure, but there are a lot of changes under the hood. So it starts with the keyword class. We are now defining a blueprint. We're naming it animal. And then you see this right here. This confuses people. And then public and QObject. Whoa, what are we talking about here? Well, this goes into scope. For our blueprint, there's some things we want the public to be aware of, and there's some things that are private, meaning we're going to keep to ourselves. We want to inherit QObject, something we're going to talk about a little bit later, where we take another blueprint and absorb that blueprint into ours. So we have all that goodness baked right in. Then we have this Q underscore object. Do you remember when we actually created this in that dialog, it had that checked? This is a macro. And if I've got my mouse over it, so you see that big ugly yellow window, that's basically what's going to be going on is we've defined QObject and it's got some things in there. And this is a macro that adds a lot of code in the background. So when you see Q underscore object, think of this as like a magical spell that adds all of that goodness into the background. You need this for this to be an official Qt Q object. So to recap, we are including Q object, another class somewhere else that Qt's provided to us. We are going to inherit Q object, meaning we are now becoming a Q object. And then we have this macro, which adds a bunch of code in there for us. All right, now that we've got that out of the way, we have some scope, and we're going to talk about scope much later on. This, again, another complexity of C++ is you have to understand all these things, and we're going through them at warp speed, but we're saying what we're going to tell the general public, people outside of our blueprint, we have this constructor, and we are explicitly stating that. The constructor has the same name as our blueprint. What this means is when the compiler creates an instance of this, it will construct it, and it will call this function. Now, you may be saying, what function? It's just a single line. This is where it gets really, really confusing. You see, when I mouse over this, it says explicit animal, : animal. We've created a scope. And if we open this animal.cpp, there is the constructor right here. This is the implementation. So whenever you're in a header and you see just a one-liner like this, that means it's defined somewhere else. This is a prototype. We're saying we're going to use this, but we're not going to define it here. We're going to define it somewhere else. And in our implementation, you see we're actually including that header. And then we are defining that right here. Or I should say we're implementing that definition right here. So here is where, well, you guessed it, we are going to be constructed. So I'm going to go in here, go ahead and include debug. And I can actually just select this and then right click and we can switch, or we can follow symbol under cursor, which will take us exactly right where we need to go. And I can just say Q debug. And let's just let's say this constructed. Now, there's a couple things here that are completely new to us, and this may look completely crazy, but basically this is the implementation of the constructor where we're saying in the animal scope, the animal function or the constructor here, we are going to give it a pointer to a Q object or a parent. This goes into a bit of advanced memory management we're going to cover later on, but basically what we're saying is we're going to give this a parent. We are a child of this object right here. And when this parent is destroyed, this object will also be destroyed with it. And then part of our constructor is we're going to go ahead and construct the public part of Q object and give it that parent. Seems like we're duplicating efforts, and we really are. Under the hood, we actually have two different things. We have a Q object and an animal. Very confusing the way that works, but rest assured, it's pretty straightforward from here. So once this object is created, this code is fired off because we're in the constructor. This will be called automatically. This is actually a pointer to the current object. If you think about that, you're making a blueprint. So let's say you have a recipe for donuts. The recipe would be the class. Ta-da! If you make multiple donuts, each donut is its own individual object in memory, and you need to know which one you're actually working with. That's where this keyword, it's the current donut, or in this case, the current animal. Let's go ahead and demonstrate this. So I'm going to jump in here. I'm going to say include, and we want animal.h. Now, this brings up another question. Someone will ask, well, wait a minute, this is brackets and this is quotes. What's the difference? So when you see brackets, that means it's going to go search out in the system path. Every operating system has a concept of a path or environmental variables. If it's in quotes, it's based off the current directory structure. So if I go here and we're in projects, if I go down to file system, you see here's the directory I'm in, and ta-da, it's right there. So if it was in a subdirectory, it'd be like dir, and then whatever the class name is. But see how now suddenly it can't find it because it's looking for a subdir and a subdir and then the class. So let's get rid of that. And now it's just right in our current folder structure here. All right, so now that we have our animal, we can actually use it. So I'm going to say animal, and let's go ahead and make a cat. Animal. Dog. And a fish. Now, we have done absolutely nothing other than said, hey, C++, we have a data type called an animal, which is our custom class. And we want a cat, a dog, and a fish. Let's go ahead and save and run. Now, typically at this point, if you got some sort of build issue, it's because you screwed up an import or there's a misspelling in your header file. But you can see we have 3 animals that have been constructed. Each one of these is at a different memory address. So we have 3 distinct objects that we have created from one blueprint. Very cool how that works. Now, to kind of wrap this thing up, I want to keep this a little bit simple here. Let's flip back here. You see this signals, don't worry about it for now, but there's a concept called signals and slots, which is how you do communication between objects. We also have, and right here, a private area where you can define things that you don't want the outside world to know. You notice how that Q_object macro is in the private area. You can also do something like this and define things here. Whenever you see this and this and this, think of these as their own little code blocks. So I'm going to get rid of that, but I just want you to be aware that's what it means when it says public, is we're telling the outside world we're going to do something. I'm going to say void speak, and we're just going to make a function. Say QString message. So we've talked about this briefly, I think in a homework assignment, where we said QString is the Qt's way of representing a Unicode character string. We're going to cover this a little later on, but right now just take it as a leap of faith that this is a string. Now, when I say string, what are we talking about? Just words on the screen. That's basically all we're talking about. Now, because we have not defined this, if we wanted to, we would have to actually turn that into a full-blown function like this. But instead, I'm just going to say, hey, we're going to define it. You can right-click, and just to slow that down, I'm on speak, and I'm going to right-click. I'm going to go to refactor, and I'm going to add definition in animal.cpp. You can also do outside or inside, but I'm going to do it in the CPP file or the implementation file. And it automatically creates that for us. That is extremely cool the way that works. And then from here, we can just do this. So we're just going to debug that out. We can change this to a Qt info if we really wanted to. Doesn't really matter. And now we can explicitly go out here and work with that function we just created in our class. So I can say cat.speak. And I'm going to say meow. If I could actually spell meow, there we go. Save and run. And you can see we've got a few different objects in memory. There's like I think this is the cat. Let me look and see which one's which. So we got the cat, the dog, and the fish. And sure enough, if we look at this memory address here, big, long, horrible looking thing, that is the memory address of, you guessed it, our cat. And the cat is saying meow. And you notice how we don't have one for the dog or the fish. Let's go ahead and implement those right now. So dog's going to bark and the fish is going to... Man, I don't know what noise a fish would make. No idea what to type here. What noise would have... Let's just do bubbles. Blah, blah, blah. I don't know what noise a fish would make. Maybe some weird dolphin screeching sound or something. So let's save and run this again and see what this looks like. And you can see now we have meow, bark, and blah, blah, blah. But it's not abundantly helpful because we just have these memory addresses and we don't really know which one of these is which, right? So let's just play around with this just a little bit. I'm going to say cat.set object name. That is baked right into QObject in case you're wondering where that's coming from. I'm going to call this kitty. And we're just going to, through the magic of copy and paste. Dog's going to be named Fido. And the fish is going to be named, I have no idea what to call the fish. Let's call him Fish Stick. Why not? I'm getting hungry. So Fish Stick it is. Should have called him Lunch. But anyway, so let's go ahead and save and run. See what this looks like. Now you can see it says animal with the memory address, but then we have the name right here. That's what the set object name is. It's just a simple way of us naming an object so we can see what's going on under the hood in memory without having to remember each and every individual little memory address. You'll also notice that these memory addresses are different every single time I run. That may not be true depending on your operating system, but most operating systems out there have what's called memory randomization, which means that memory will not get reused. It will try to find an empty address. So quick recap, because I know we covered a lot here. We have made an animal class. We are inheriting QObject. We're using the QObject macro. We've talked very briefly about scope, signals, and slots, which we're going to talk about later. We've talked about the constructor and how we're going to set the initializers for that constructor. And we've made a custom function. And if we go into the source, we actually implemented that. We also touched upon the object lifecycle. There's a constructor and something we haven't talked about yet, a destructor, when the object's actually destroyed. And we talked about how to define things using the set object name so we can see them stand out. Quick little recap on that. In case you're still scratching your head on set object name and where that came from, it's actually part of QObject. You see how as I moused over this, it's saying QObject : set object name. So because we've inherited QObject, we have all the functionality of QObject baked right in. This video is going to talk about constructors and deconstructors. Why? Because we want to talk about the object lifecycle. This is not specific to Qt. This is a C++ thing. Actually, most programming languages have a concept of a constructor and a deconstructor. However, what we want to talk about is the object lifecycle from the perspective of Qt. And remember, we talked that QObject does not like to be copied, so we have to handle things a little bit carefully here. So let's go ahead and right-click, add new, and we're going to make a class. And now that we've done this once, I'm going to go through this a little bit faster each time. I may even start videos with classes already pre-made. We'll say laptop. From here, what we want to do is take a base class. And remember, it's going to include QObject and add that macro. It's going to recommend some file names. We can change this if we want. I'm going to change this to uppercase, and notice it does not change the file name case. I'm going to hit next and finish. And no, I don't want it to copy it. I'm just going to say laptop. Super easy for us to do. Now, somebody out there is going to say, well, CMake is incredibly powerful, and there are scripts and functionality out there where you can include all the files automatically. Why aren't you doing that? Because I don't want to. I want to show people how to add these. And also, it does become a security concern, and I don't want to take that bad habit through somebody's lessons into eventually their career, and then they get in trouble for doing that. That's actually one way that hackers will infiltrate a program, is they'll sneak a header file in there, and some would-be developer compiles it and doesn't realize it, and then the program is completely altered. So it gets way more in depth than that, but you will not see me automatically include these things. All right, now that we've got our header and our source, let's go ahead and look at our laptop. Strikingly similar to the previous video because, well, it's very simple. We're including QObject. We're inheriting it. We've got that macro in our private section, and we have our constructor. Let's go ahead and add in. Don't really need it because it does it automatically, but just in case you need it, qdebug. So we've got our constructor, and I'm going to put a comment right here. And I want a deconstructor. This is when the object is destroyed. So when it's created and when it's destroyed. The syntax for this is a little bit, well, I'm just going to say it's a little bit weird. But basically, it's the tilde. And if you don't know what a tilde is, it's on the keyboard. Look over on your top left by the number 1. You're going to probably have to hit Shift. And then that character, which looks like that if you don't hit Shift. That's the tilde, or tilde. Laptop, so you want the name, and then it's just a normal function. That's all there is to it, really. That's it. It's really not super hard. Now you notice up here in the constructor, it says QObject, a pointer to something called parent equals null pointer. That's different than saying 0. That's saying null pointer, meaning it's just simply not there. It's never been set. I'm going to do a comma and a QString name. So we're going to add in our own special little property there called name, or actually that's a parameter. You see this light bulb appears. It says apply changes to definition. If I don't click this, that means that this right here does not match this, and we'll get some sort of error. You see this out of line definition? That means it just simply does not match the declaration that's in the header file. Those two have to match. So when you see that little light bulb there, that's a super friendly way of doing it, but I can't get it to reappear. I'm going to delete that out, save it, and let's try that again. Notice how the light bulb's back. And if I click this light bulb, it will change it automatically for me. And then we get this other thing, missing default argument. Now, why are we getting that? This is super frustrating in C++ land, but whenever we have this equal sign, we're telling it what a default argument is going to be, meaning what is it going to be if we simply don't include the information when we call it. So big leap of faith moment, we're just going to say equals and then some question marks. If you didn't want to mess around with that, you could simply move it before. You could do it like right here. Wow, misspelled name. That's horrible. But I wanted to show how we would add that in. Now, if you can't get that light bulb to appear, very simple. You just grab this, switch over to the source, and then paste it in here, minus the defaults, meaning we're not going to say null pointer or anything like that. Super confusing, I know, but again, this is a course on Qt programming, and that's all C++. I did tell you I was going to give you just enough C++ to survive. All right, so now that we have that, let's flip back into our header, and we're going to implement this deconstructor. In case you missed it, I'm just going to mouse over, select it, right-click, refactor, and add definition in CPP. If, for whatever reason, you can't get that menu to pop up, you can very easily just type this out. I'm going to type it out just for demonstration. So we're going to say laptop, and then colon, because we are in the laptop scope. We want the tilde laptop, because that's our deconstructor. And then it's just simply a function. Very, very simple the way that works. Now I'm going to add in some other things. So for example, notice these are in the public section, so the entire outside world will see this. And I'm going to add some functions here as well. So you can tell the difference between a variable and a function because the function will have these parameters. Or I should say these parentheses, and they could have parameters in there. So for example, we could say parent, or QString name, or whatever we wanted to do here. But for right now, they're just going to have no parameters. However, because they're functions, we also have to implement these. So if we were to try to build this, and let's see if it builds. Be kind of surprised if it did. Yeah, no return statement. It actually built that even though we don't have that test in there. Usually that throws an error message for me, but we can add it in super quick. Might demonstrate that in a little bit here. Now we've got our functions, and I'm going to say QInfo, this, and our name. Let's just differentiate this. That way you know what we're talking about here. I'm going to say this name equals name. So what I'm doing here is I'm saying this current object set the name to this guy. So we have a variable called name and, of course, a property or a variable called name, two different ones. And there's a copy happening under the hood here. So you notice how this is not a pointer and it is not the address of or a reference, it's a copy. So we're literally just going to say, make this equal that. Super confusing, I know, but that's how that works in C++. You could, if you wanted to, simply omit this, and it is the same thing. Now, this is where it gets a little confused, and it says explicitly assigning the value of a variable of the type QString to itself, meaning it thinks you're trying to use this instead of this. And that's why we use the this keyword. Can we say this in the tutorial anymore? I really tried to script that better, but I often try to do my videos unscripted. I legit did try to script that part though. So from there, we simply have our constructor. Now to simplify this, speed this up just a little bit, we've got our deconstructor. And then we have some functions here. So as kilo, we're going to say return this dot wait. And again, you don't really need the this part. You can just say wait, and it automatically knows that it's part of this current object. We're going to multiply that by 0.453. Again, I'm cheating. I'm going out on Google on a different monitor. So 453592, and that would convert pounds into kilograms. And then test, I'm going to just grab this, and we're going to play around just a little bit here. Say this, test, and then I want to do the name, and then kilo, just to demonstrate that we can call a function from our current object. So the real question people are going to ask is, should you do this as kilo or just as kilo? It really doesn't matter from a compiler's perspective because it's going to do virtually the same thing. To be brutally honest, I tend to omit the word this unless I need that actual object for some specific reason, like you see in these QInfos. So to quickly recap here, we've created a blueprint called laptop that's inheriting QObject, and it's got the QObject macro. We have a constructor, a deconstructor, and then we have some properties here, which are variables. And we have some functions. That is our blueprint. You notice these are all in the public scope, meaning the outside world can see these. So let's go to the outside world. We're in main. We're going to include our laptop. Now that we have this, I want to make two functions. First function I want to do is I want to do a void test. And I want to work with a laptop, but of course we have to be very careful not to copy a laptop. So I'm going to say laptop and machine. So we're going to say address of machine, or we're going to pass it by reference, not by value. We want to avoid a copy at all costs because Qt will not allow it. And I'm going to say machine.test. Very cool. Now let's go ahead and make some laptops. And I'm doing this specifically in a function so we can see the life cycle here. So I'm going to say laptop, mine, and The parent here is null pointer, so we don't have a parent to give it. If we wanted to, we could pass this Qt core application as a parent. A little bit more advanced than where we are right now. Don't really need it, so I'm just going to say null ptr for null pointer, meaning we don't want to set it. And then I'm going to say for the name, my laptop. And then let's call this one yours. Now, someone out there is going to say, well, isn't null pointer the same as 0? Not really specifically. It does get translated to it, but they are kind of two different things. And this one's going to be your laptop. Now, I say kind of two different things. In harsh reality, it is pointing to a 0 in memory, just because I know somebody in the comments is going to say, wait a minute, I found this out on the internet and it says you're wrong. You're probably right. I probably am wrong in that statement. But we're going to use null pointer because that's a cute way of doing it. So we're going to say mine only weighs 3 pounds and yours weighs 5. Now let's go ahead and test these. So I'm going to say test mine and test yours. Now there's a bit of magic going on here. We're doing this on the stack. We're talking about memory now. So the stack, we're letting C++ manage this memory for us. We've created this, or I should say C++ has created it for us on the stack. Remember, the stack is the region of memory that the compiler or your program will manage automatically. Because it's managed automatically, it's going to delete it when it's no longer needed. And I should word that differently. The stack's not actually deleting it. C++ is, but will be deleted from the stack. And this happens automatically. And it's doing that because it's in the scope. That's how the stack typically functions, is once something goes out of scope, right here, talking about these laptops, they're no longer used, they're out of scope, it will automatically get removed from memory here. So let's go ahead and test this out. We're going to do make laptops. Save and run. And sure enough, we have my laptop constructor, your laptop constructor. So these have both been constructed in memory. In case you're wondering where that is, it's right here. It's our constructor. Then we are testing them and getting them as the name and the kilo. And then we are destroying them, or I should say it's destroying it for us automatically. That is being called right here in our deconstructor. And remember, it's got this funny little symbol in front of it. That's how you know the difference between a constructor and a deconstructor. Both should have the same name as your actual class, but the deconstructor has this funny little tilde in front of it. Now, you notice this happened automatically, this deconstructor. We didn't have to do anything. That's the dangerous bit with automatic memory management, is we don't control this. It's just going to be wiped out. So you notice how right here we have this address of, we're passing it by reference. If I get rid of that, suddenly we get this implicitly deleted copy constructor. Because what's happening is we're telling the computer, construct this right here, and then here, it would be automatically deleted. And that's bad. We don't want to do that because we're still trying to work with these things. So that is why you'll see me working a lot with either the by reference or with pointers, and we're going to talk about pointers a lot more. So the major takeaway from this video is you can start making your blueprints rather complex, and each one of these objects that we construct from the blueprint has a constructor and a deconstructor, and we have a full object lifecycle, and C++ can manage that lifecycle for us. So we got to be a little bit careful about how we pass these objects between functions, because C++ will try to manage that memory for us. Inheritance is, well, a complex topic, but to clarify, it's a class that gains the members of their base. Think of it this way. For example, let's say we have a base class called person. It's a very, well, boring class. It doesn't have any hair color, skin tone, gender, age, or anything like that. It just represents a person. Using inheritance, we can create a number of different classes. For example, we can create a class called Mark and a class called Jane. They are two totally different classes, but at their base, they're both people. They both inherit the person class. This video is going to talk about class inheritance, and this is arguably one of the more challenging aspects of C++ to really wrap your head around. We're going to try and make it super simple, but I'm going to have to defer to my notes several times just because we are talking about a complex topic here. So, for example, let's say we have a square, a humble little square sitting out in the world doing its own thing. And let's give this a nice green color here. And let's say we want to inherit that, but we want to change it slightly. So it's going to be kind of like this. That's called inheritance. And we've done this before where we have a Q object and we make our class which inherits the properties of Q object. It's a completely different class, but it still has all the properties baked into it. One of the challenges here is you can take this to some sort of extreme. So for example, you could do something like this, have this type, and then have this type, and then have this one. They're all different, so we're going to give them different colors here just to represent they are different. And boy, I'm running out of colors here. So let's give this one red. Let's give this one a blue. I'm just randomly grabbing colors here, bear with me. And then let's give this one a pretty hot pink. Why not? So anyways, point being, we have a Q object. We've created some sort of diamond class using Q object. And now we have like a red diamond, a blue diamond, and a pink diamond. You can do this. And in C++, you can take it to an even further extreme where you can say, you know what, now you want some sort of circle that inherits from this, but also you want to take this pink diamond and put it inside that, and then take this red diamond and put it inside there as well. Let me kind of just move these off to the side. So you get kind of this monstrosity, and this is called multiple inheritance right here. I'm going to demonstrate how C++ can do multiple inheritance, but Qt does not like doing multiple inheritance. Qt likes a nice straight downward. It doesn't like doing this multiple inheritance. Now, in case you're wondering how to get around this, it's called interfaces, which is something we'll talk about in another video. But this video is talking about inheritance. So let's flip in and take a look. I've got just a very simple application. There's absolutely nothing in it. And we're going to make a humble little class here. Let's go ahead and add new. This is going to be our animal class. It's going to be a Q object. Next, next, finish. No, I don't want to add that in automatically. Type that in, save it, and ta-da, magically appears. So in our animal class here, we're going to say include Q debug. And then we want to, what is the basic property of an animal? Well, it has to be alive. At least it should be alive if it's an animal. So we're just going to say it has to be alive. And I'm going to do it right here just because I don't want to put it in the implementation file. I'm just going to return true. Very simple, probably the easiest function you will ever write in the history of anything. Now, in our implementation file, I want to observe, I'm just going to copy some things off the screen here. I want to observe this being constructed. Notice I was just going to say qinfo this constructed. Very, very simple the way that works. So if I go out here, let's go ahead and include animal. There we go. We can just simply get rid of that guy. Simply use it. Save, run, we've done this before. This is not rocket science. Now we have inheritance. We have created a class that is inheriting Qt object. Qt did a lot of that heavy work for us. We're going to start doing this manually now to show you how we can really play around with this. So for example, I'm going to go here, right click, add new. I'm going to add a class. I'm just going to do this a little faster. We're going to make a mammal. I think mammal is actually 2 M's. This is also going to be a Qt object. See? And next. And no, I don't want to add that automatically. Thank you very much, Qt Creator. Now, notice how mammal is a Qt object. Well, I want mammal to inherit animal because mammal is an animal. So I'm going to say include animal. And let's go ahead and add in Qdebug real quick. Now we're faced with some fundamental problems here. We are further down on the inheritance chain. So for example, we've gone from Qt object to animal to mammal. So we want to inherit this right here, this animal. We need to change this Qt object to, you guessed it, animal. We're inheriting the public aspect of animal. So if we go into animal, this is what we're inheriting, the public aspect of that class. Not quite done yet. We need to switch in here, and you notice how it still says Qt object. We need to do animal. So we're still going to inherit animal, and we're going to set those constructor parameters here. Now, mammal is slightly different than animal. It is an animal, but it's slightly different. We're going to say bool has backbone. I think all mammals have a backbone. That's one of the defining characteristics, I believe. Not a biological expert. And that's just going to return true. Very simple little function, doing this right in the header. Don't need to mess around with anything else. And I'm going to beg, borrow, and steal this and put this in the mammal constructor. Pretty simple the way that works. So now we have a clear inheritance chain. Now I want to take this even just ridiculously further. Close all this stuff because it's getting kind of complex here. I'm going to add new, and I'm going to just kind of whip through these real quick. I'm going to make a dog. And then I'm going to make a cat. Again, we've done this. You can feel free to rewind. I'm just going to whip right through it. There's no sense of wasting a lot of time. Also kind of demonstrating just how fast you can do development. I'm not even going at full speed. I'm still kind of slowing things down just because I'm trying to demonstrate this. And we're going to grab this mammal stuff here and flip right into canine. I'm just going to be doing a bit of copy and pasting. Actually, I don't want animal. I want mammal. Assuming I got that correctly. Yep, I did. All right, so what I'm doing now is I'm saying the canine is a mammal, which means it is also an animal. That's called an inheritance chain. So let's switch here. Now, if you get this type issue here, really that's just the compiler trying to catch up, figure out what I'm doing. So sometimes you'll get typing a little faster and you'll see these random errors pop up, and then as you type or save, you'll see them magically disappear. That's exactly what's going on. The only time you should really be afraid is if you do something like this and it doesn't go away. So I've got 2 errors on the screen. Initializer mammal does not name blah, blah, blah. what that's really saying here is it has no idea what mammal is and why we're trying to inherit it, and then calling info with incomplete return type QDebug. That means we're missing an include. See, incomplete return type QDebug means it has no idea what we're doing here. So let's go out and fix both of those now. We go into feline. We're going to inherit mammal correctly. And we've included QDebug, so it should, if I flip into feline, clear both those out. Ta-da! Magic. All right, so let's close a bunch of this stuff. Save all. I have a creaky chair. I don't know if the microphone just picked that up, but man, my chair just creaked really bad. All right, so we've got our canine, and I'm going to add in a function, bark. And I'm just going to do this all on one line just to show that we can do it. I usually don't do it this way, but... So the dog's going to bark. And we can add another one-liner into our feline. All right, so cats tend to meow really loud when they're hungry. Flip over to some notes here, just to demonstrate what we're doing. Now that we've got these classes fleshed out, and I realized that was a whole metric ton of copy and pasting, forgive me. Well, I'm going to delete this include, and we're going to include our feline, our cat, and we're going to include the dog, or the canine. And we're going to create two of those. So I'm going to say canine, dog, and feline, cat. So there's a couple things happening here under the hood, and what's really going to demonstrate it when we run it, but I want to talk about it really quick. We're saying canine, so we're saying C++, we have a data type called canine. It's going to open up our H file and say, okay, canine is a mammal. So it's going to open up mammal and say, okay, has all this, but it's also an animal. It's going to open up that and say animal is also a Q object, and it's going to start from the top, and it's going to add all of the properties and methods and functions and variables and all that goodness from Q object, and then from animal, then from mammal, then from canine. It's going to construct this object in the background. So it's going to do the same thing for feline. And I'm going to just comment out the cat just so we can see just the dog. Let's go ahead and run this. Notice that took slightly longer to build, and sure enough, animal, mammal, canine. So we're actually constructing three things, even though we're just creating a dog. That's the inheritance chain at work. You don't see QObject because I don't have direct access to the QObject source code to put that Q info in there, but it's happening right above this animal. So it's creating QObject, animal, mammal, canine. It's going right down that whole inheritance chain. Now, because this is a dog, we can do things like this. Notice how we have all of these beautiful things. This is all of that inheritance smashed into one, and we even have these deconstructors. We have a QObject deconstructor, a mammal, an animal, and a canine. And then we have all of this stuff. So we can bark, for example. And that is coming, if we mouse over here, from canine bark. Notice it's canine. And if I do a QInfo, actually I don't need this right here. It's causing an error. QInfo dog dot has backbone. Notice how it's saying mammal has backbone. It's smart enough to know where we're inheriting that from. And then QInfo dog dot is alive. And sure enough, animal is alive. And we can do things like set object name, which is coming from QObject. So there's the inheritance chain at work here. Now, I want to get rid of that and that and show you what's going on when we construct both the dog and the cat. You can see there's a whole lot of construction going on here. it starts with the dog and it builds that up, and then it starts with the cat and it does the same thing. So point here is it's starting at the top and building this object in memory with all of its parents and base classes and things of that nature. Very complex little dance. It does all of it for us. Now, what I'm going to introduce here is, well, something I really dread doing. But someone out there is going to say, but can't C++ do what's called multiple inheritance? Couldn't you make some like hybrid monster of a dog and a cat combined? Why would you want to do this? As some weird mad scientist, I don't know. But let's demonstrate. No, it cannot, or I should say, should not work. So I'm going to say monster. And we're just going to do a QObject as a base class. Next, next. No, I don't want to do that automatically. Let's jump into our CMake list. Oh, we're already there. I'm going to say monster and monster. Let's add those files in. All right, now we've got a little bit of an issue ahead of us. Monster is going to be a conglomerate of pretty much all of these. So I need to include feline and include canine. Let's go ahead and try to include QDebug here. Now, our first hurdle is we want to inherit QObject, but we also want to inherit feline and canine. Notice how they're just comma separated. It's all in the public scope. We have our beautiful little constructor, and I'm not going to add a whole lot here. Let's go ahead and switch into the source. Now we have our constructor here. We're going to say feline. We need to give it a parent. And that could be a null pointer. Basically, we're just giving it the same parent. So that's going up through this stack. Let's say we're creating a feline that has a constructor property of parent, and we're just saying, well, the mammal should use the same parent and the animal should use the same parent. So it's just going backwards up that. And then let's go ahead and do the same for canine. All right, now let's give that a good build and see if anything magically explodes. And boom. Before we've even tried to use this class, we've got a whole bunch of problems. You see the QObject is ambiguous base of monster. We've talked about the word ambiguous before. Whenever you see the word ambiguous in C++ land, that means C++ is confused over what you're trying to do. So we have created this right here. This is the monster, this is the feline, this is the canine, and it's saying, well, wait a minute. These all have the same base class, and now I'm super confused about which one it actually is. So you, the developer, need to tell me, what is it? And it's for this very reason that Qt tends to shy away from multiple inheritance, because you get these weird error messages. Is there a way around this? Yes, but as a general rule of thumb, I'm not going to show you because it's just going to confuse the issue further. The ambiguous base of monster is to separate them and not even really use QObject, although with C++ there are ways around that, but Qt should not allow that. The reason why is because this inheritance stack, when we create something, we want a clear chain here. So rather than using multiple inheritance, you should use what's called an interface, which we're going to cover in a future video, which basically takes this and separates it and says, okay, there's no longer an inheritance chain. You just have these fragments, and I'm going to change the colors here just to show that they are completely different. And you can take these interfaces and add them to a class. That way you can add in specific functionality without dealing with the complexities of multiple inheritance. In the last video, we talked about multiple inheritance and how you're going to get ambiguous name and all sorts of other crazy errors, and that there's a better way of doing it. Now, there are many, many ways of doing this, but I'm going to show you what I believe is the best way, which is interfaces. So what is an interface? Well, it's a contract between objects. Think of that. It's a contract. It's saying that you, an object, will include some sort of thing, whatever it is. Let's take a visual representation here. So here we have inheritance. Here's Q object. We make something, and then we can make other things by inheriting that thing. We have a clear inheritance chain. The problem comes in when we do multiple inheritance. We use the monster class, which was both a cat and a dog, and it got really, really confused. What we're going to do now is break that inheritance chain and instead have interfaces, which is a way of saying, and let me just pick some different colors here. It's a way of saying that the object itself will have these functions baked into them, and this is what we can expect. So we are still inheriting using multiple inheritance, but we're using interfaces instead of an inheritance chain. There's a massive debate over whether inheritance is actually an inheritance chain or not. We're going to demonstrate. To do this, we're going to need help of a virtual function. Now, virtual function is very advanced. We're going to try and overly simplify it. A virtual function is a member function which is declared within a base class and is redefined or overridden in a derived class. What? Basically, what that means is we're going to make a class that does absolutely nothing, and then we're going to inherit that class and then do something with it. That is just freaky. Let's go ahead and take a look. So we've got absolutely nothing in here. We're going to make 3 header files. We're going to make a toaster, a freezer, and a microwave. And these are going to be classes. So I'm going to say, let's go with right click. I can grab it here. There we go. Add new. And instead of doing class, I'm going to say header file. And let's call this toaster. Notice how it just simply doesn't even prompt us. It doesn't do anything. It just thinks we know what we're doing. It's on us to figure that out. So toaster.h, save it, and then voila, it's there. Notice there's no implementation file. It just says, hey, this file is not even part of the project. Oh, interesting. So what we're going to do here is we're going to actually build a C++ class. This is not going to inherit QObject at all. So I'm going to say class toaster, and then we need the bare minimum in here. So we're going to do the public scope. Very important you do this part. If you skip this, you're going to have a bad time. And we want to use what's called the virtual keyword. Virtual is telling the compiler that we're going to define a function, but we're not really going to define it. We're going to actually just prototype this out. So we're saying, trust us, compiler, we're going to use this somewhere, somehow, but we're not going to actually implement it here. We're not even going to fully define it here. So bool grill does toaster's grill, and then operating system specific. This 0 should work most of the time. What we're doing here is we're saying equals 0. We're telling the compiler this is virtual and we don't have any implementation at this time. There's none of this. I think Windows with the Microsoft Visual C++ compiler may have to do something a little bit different, but 99% of the world out there can just say 0. Notice how this is not inheriting QObject. This is a class in itself. This is the basic, probably the most basic interface you could possibly make. What this is saying is we're going to make a different class. We're going to do it later, called an appliance, which is going to inherit toaster along with a freezer and a microwave, and then we're going to implement this virtual function. So I'm going to just grab this, then add new, and I'm going to do this rather quickly here. We're going to make a freezer. And then let's go ahead and add in a microwave. save our CMake list. It should automatically detect them and open them up. I'm just going to copy and paste this, rename the class. And so the freezer is going to, what should a freezer do? Well, it should freeze. And then microwave is going to, of course, microwave things. All right, so getting a little ridiculous here, but actually I don't want to call it microwave, I'll just call it cook, because it's going to cook our food. But all of them are, well, interfaces. Now an interface is a contract between objects. So we don't actually have an object yet. We haven't really even defined it. So what I'm going to do now is I'm going to make an appliance that's going to be able to freeze, microwave, and toast all in one shot. So we're going to inherit all of those, or I should say implement all those interfaces. So I'm going to right click, add new, and now I'm going to do a C++ class, all this appliance. This is going to have a base class of QObject, so we're going to include QObject and the QObject macro, which adds all that goodness in there for us. Now suddenly it's very concerned about what we're doing. All right, so appliance H and appliance.cpp, or our implementation file, add those in. I'm just going to do a little maintenance here and close a bunch of this stuff here. So in our appliance, we need to include our interfaces. So I'm going to include the freezer. I'm going to include the microwave. And let's go ahead and include that toaster. And just for giggles, I'm going to include debug. Now comes the fun bit. We're going to do multiple inheritance. So we've shown this with Monster, how it freaked out and died, and all of that was because of this inheritance chain that we had up here, where it was a QObject and this, and then all of these are QObjects, and it's saying, now which one of these QObjects did you actually want to initialize in the constructor? And that's what it was really freaking out about. Don't have to worry about that now because we have different classes that don't have an inheritance chain. So let's go ahead and do this. I'm going to say, comma, public freezer. And anybody who's really, really good at watching the video noticed that I omitted public almost intentionally in the last video, although I didn't mention it. And that's what really helped drive that error message on the screen. One of the reasons anyways. Toaster and microwave. And oh, that is a lowercase. I was wondering why it didn't want to do an uppercase there. Case sensitivity matters in naming, so gotta definitely make sure we have the right case sensitivity there. So now that we have these, let's go ahead and put in the public for each one of these. We can do a little magic trick. We can, instead of typing all of it out and implement it, we can just right click, refactor, and then insert virtual functions of base class. Notice it's virtual functions, meaning it's smart enough to know it's going to go out here and see, oh, this is virtual. We have created an interface and we want to implement that interface. So we're going to right click, insert virtual functions of base classes, and we get this beautiful little dialog here. Notice how it's not just the one we selected. It knows, hey, we're trying to do microwave, toaster, and freezer. This is extremely cool. We already inherit QObjects, so that's not selected, although you could try to do that and it's going to freak out on you. You have some other little options here, like add virtual to function or override equivalent. I'm not going to mess with any of that. You can do insert only declarations or insert definitions inside a class or outside a class or implementation file. I'm going to do insert definitions in implementation file. And what that's going to do is actually update this appliance.cpp. Let me move this out of the way. It's going to update that in the background. So it does this ugly monstrosity of a code. You don't need all these public sections here because it's already in public. And now we can just move this up here. Now it's already in public. Before it was in signals. And we can switch over to our code and ta-da, it's all there. It's already ready to go. Non-void function does not return a value. That's really all it's complaining about at this point, is that we're trying to return something. So can we cook? We're going to return true. And then I'm just going to return true for all of these because this is the appliance 3000. Does everything we want it to. This is extremely cool. And I'm going to add some Qt6 in here just for giggles. Actually, I have QInfo. So this is extremely powerful. What we've done here is we've created a fairly complex object that has, well, 1, 2, 3, 4 things that it's inheriting from, but it has a clear inheritance chain to QObject, and the rest are interfaces. So you may be scratching your head going, what is really the difference between an interface and inheritance? I'm going to let you in on a little secret. They're pretty much the same thing. The only real difference here with an interface is that you should have everything as a virtual function. Now, you may find some little gotchas and scenarios and situations where it's slightly different on your operating system depending on what you're trying to do. You may have to actually, if you're going to use these via pointers, implement a deconstructor right here in the class, but we're going to keep this super simple for now. Now, let's see this in action here. So I'm going to grab my notes. We're going to go in here, debug, and let's go ahead and add in our appliance. And we're going to say appliance. Let's call this the, I don't even know what to call this, machine 3000. Now, if you ever get something like this, where it's saying unknown type of name appliance, even though we know there's an appliance, usually you can go in here and see you've misspelled something or it's not spelled the same way. So I'm going to grab that and grab this. Save it, should fix it. So if you horribly misspell something like I tend to do, check the spelling, check the naming. Usually what I end up doing is accidentally doing like a lowercase, and then it's going to freak out on me later on. So now we've got our machine 3000 here. And I want to just say QInfo cook. Can we cook? And then you guessed it, we're going to check this real quick. All right, let's give it a good build, see if anything explodes. And we've got a clean build. And if we run this, it works as expected. Our appliance was constructed. We can cook, we can freeze, we can grill. That is interfaces in a nutshell. So, quick overview. Interfaces is a fancier way of doing multiple inheritance, and I should say it's even the correct way of doing it. And what we're doing is we're doing non-Qt classes with virtual functions. Now remember, a virtual function says we're going to have a function, but we're not going to implement it here. We're going to have to implement it somewhere else. And then after we did that, we made a Qt class, I should say a class that inherits a Qt object, and we added in the inheritance for freezer, toaster, and microwave, right-clicked, tractor, and then insert virtual functions of base class, which allows us to add all this stuff in automatically. And from there, we just simply implement the code, and it works. Really smooth, really easy. You don't have any of that, C++ getting confused about what it's supposed to be doing. What we're going to talk about next is overriding. And it's a little bit complex, and a lot of people like to spend a long time talking about this. We're going to overly simplify this because, again, this is a course on Qt programming, and we're going to teach you just enough C++ to get by. So, overriding, what really is it, and why do we need it? Well, we want to change the behavior of a base class. Let me explain here. So we've got a Q object, and we are inheriting that from a feline class. We're adding a function called speak. We are now making a lion class, which inherits feline, which means it also inherits QObject. And the lion has another function called speak. How do we know which one of these speaks being called? Because as we've seen in the past, if we create this, a feline and a QObject are also being created, and feline already has that function in there. Oh, a lot of people like to make this super complex. So we have our feline class, which is inheriting QObject, has a function called speak, and if we just go in there, it's just going to simply print out meow. As terrifying as speaking cats are, we're just going to make this class anyways. Now, lion does not have anything, it just inherits feline, which means it has a speak, but that speak is being called from the feline class. And to really drive that point home, if we mouse over, I've already got lion in here, Leo speak, you see it knows it's calling it from feline. It's saying feline : speak. So in this diagram, it's actually going to call this one right here. We want to switch that down here. It's actually very straightforward. A lot of people like to make this harder than what it needs to be. I'm just going to grab this, go into lion, and whoops, Control V, there we go. We're just going to add it in, same name and everything. Now it's going to be under the lion speak. I'm going to right click, going to refactor, and add definition. And we have a blank slate to work with. I'm literally just going to copy and paste the same code from the feline into the lion just to save time, and I'm going to make this roar. Now, if I save and run, you'll see that the lion will roar, in fact, because we're calling it off the lion. So now, if we flip back to our diagram, we're calling it off this guy down here instead of this one. Very simple the way that works. And if ever you're confused, you can go into the IDE and just mouse over it, and it's going to tell you exactly where it's pulling it from, lion speak instead of the feline speak. But what if we're in the lion and we want to call the feline speak? And this is where the complex conversation really comes in here, where you're here, but you want to call this function up here. How do you call that? Do you make a new feline? No, you don't need to, because watch. When you run your class, feline's already created and exists in memory. It's already constructed. We just need a way of accessing this, and this is called the base class because we're inheriting from it. And it's very simple, very straightforward. You're going to say feline, and then the name of the function. Because remember, feline already exists. It's right here. We're inheriting it. So we're just going to call feline and then call the function. So this is what's called calling a function from a base class. Save and run. And now we should see roar and meow. So it is calling it from feline. Again, this may seem overly complex, but once you really wrap your head around it, it's pretty straightforward. You just need to know what scope you're calling it from. Are you calling the feline speak or the lion speak? Because we're in the lion class, we're calling speak directly. We want to call it from a different class, we need to use that class's name. One thing that often mystifies newcomers is, well, QObject itself. It's the base class for, well, pretty much every Qt class. I say pretty much because when we get into more advanced topics like generics and templating and things like that, QObject, as you've seen, does not like to be copied, so it doesn't play well. Therefore, it's not all, it's most. But let's take a deeper look at QObject here. So I'm just going to, and let's right click here, add new. We've done this before, you're not seeing anything brand new, but I just wanted to slow this way down here. So base class, we've kind of taken this list for granted. Custom, yes, you can do whatever you want, but we've been saying QObject, and notice it's smart enough to say include QObject and add the QObject macro. But what are all these other things that we've been ignoring? So first off, widgets in main window, those are part of, well, the Qt widgets, which is displaying desktop style applications. You're actually looking at one right now. This dialog, this define class window, and Qt Creator itself are written in Qt with Qt widgets. Then you have Q declarative item. What? This is way advanced. We're not even going to really touch on this, so don't even pay attention. And Q quick item. This goes into QML. We talked about at the very beginning of this whole thing how once you leave Qt Core and you go into the graphical layer, you can either go with widgets, what you see now, or QML, which is rendered pretty much everywhere from TV, smartphones, desktops, you named it. It's their newer graphics. That's why we're pretty much just staying with QObject. Now, you also have to understand that if you include these things, you also need to include the graphical layer, which we don't want to do. And then, no, I don't want to copy that. We're going to go in here, and we're going to say test.h and test.cpp. There's some other things going on here as well. You'll notice right off the bat, Find Packages is looking for components core. So this is just the core library. As you get more and more advanced, especially if you go into my intermediate or advanced course, we're going to be working with things like concurrency, threading, networking, you name it, we're going to do it. But we're micro-focused on core. So what really does core bring to the table? Well, other than just some of the things we've been talking about. The biggest of them all is QObject. Now, we've touched on QObject being the base class, but why is it the base class? What are we really talking about? And then this macro here that we've kind of just said, well, it's a macro and you need it. And honestly, if you look that up on Google, most of the responses you're going to find are people going to say, well, you just simply need it. But they don't really explain why. A real hint here is at the very bottom where it says Qt's meta object system. We talked about the compilation process and how Qt kind of changes that a little bit. And at the very last minute, it comes in and it does what's called mock or meta object compilation. What's happening in the background is as your program's being compiled, it's looking through all these classes and going, oh, this is a QObject and it's got this macro, so I need to create meta information. We're going to go out to the documentation, and you can either Google this, you can literally take QObject and Google it. If you do that, spoiler alert, make sure you're on the right version. There are some minor version changes between previous versions of Qt and the more modern version. But this is huge. I mean, their documentation is, well, world's class. You can see, I'm just going to scroll very, very quickly. It's massive. That is how much functionality is inside of QObject. And you can see how to get this, you need to add the core, or in CMake, do the find packages and then target link. If you're ever confused, CMake is the build that we're going to be using. Ta-da, CMake. QMake is what we've used in previous lectures and previous courses because that is Qt's proprietary build system. Obviously, their proprietary build system is much cleaner because it is defined specifically for Qt. Now, inherited by, we understand the concepts of inheritance. What we're talking about here is, well, these are all the classes that use QObject, and you can see there's just a lot of them, and my browser just kind of stops trying to figure it out. There we go. Then you can list all the members. We're not going to really do that now, but you see all these connections and things like this. Connect, disconnect. What are we talking about here is signals and slots. This is one of the mainstays of QObject. This is why you want QObject, so you can communicate in virtually real time between two objects. So you can take two different classes, for example, car and dog, and make the dog chase the car, or if the car honks the horn, the dog runs away, those kind of things. You can do it very simply, and we're going to cover those kind of things in later videos. Now, the public functions, remember, whenever you see the keyword public here, that means it's available to everybody. Everybody can use these. You've got your constructor, which is your parent. Right here is a null pointer. This gets into how Qt handles memory management. We're going to talk about that in future videos. And our deconstructor. But then we have things like block signals, children. When you see children, you're thinking of an object tree. So yes, your object that you created, because it's a QObject, can have children in it. So you can make like a classroom and have students inside of that. And then in memory, when you destroy the classroom, all the students are destroyed. And that's really morbid now that I say it out loud, but I thought it was a good example in my head. Point being, there's a lot that gets added in just by inheriting QObject. And this is arguably the pinnacle of using Qt. You need this if you want to do anything Qt related. It's even got help for threading built right into it. So pretty much anything you can think of, you want to use QObject. And you get this handy little delete later. So if you want to use memory management and you don't want to delete the object now, you can actually signal garbage collection in the background where Qt is going to track that and try to delete it later. And then signals and slots, we haven't really touched on those a whole lot, but basically you can create a signal and throw it out there and say, hey, something's happening. And then one or many other objects can use that in what's called a slot. Think of it like plugging into an outlet. You are now connected to it and you get real-time information. But let's reverse real quick and go back to our humble little class. So we gain a lot of functionality just by being part of QObject. And if you're ever in the IDE and you question something, just highlight it and press F1 on the keyboard, and it brings up the help system. You can F1 again, and it takes you to the full-blown help system, which is literally the document we were just viewing. So don't think you got to crack open a web browser every 5 seconds. It's literally baked right into the IDE. Also, this macro, we haven't really talked about this. Let's dive in. So if we go in here and we just Control F for find, it's baked right in. If we click it, it's going to say the Q_object macro must appear in the private section of a class. What does that mean, private? It means it's not available to the outside world. So for example, if I go in here, and we're really getting into scope, but if I say test H, and let's say test T dot, you can't say Q_macro. It's just simply not going to let us do it. So these are the publicly available things. And you can see how you have signals. Whenever you have that little bar with a little, I don't know, like Wi-Fi signal coming out of it, that's a signal. And then you can have slots. And let me see if I can find one in here. Yeah, this little indentation, it looks like an outlet almost from the top down. That's a slot. So a signal would emit something and a slot would consume that. All of that happens because of this humble little macro right here, which is in the private section. It's not available to the outside world. And if we really dive into this, really what it's going to tell us is it's for services provided by Qt's meta object system. Doesn't really tell us a whole lot about what's going on. I almost dare them to be less descriptive, but if you look up the meta object system, they have a whole document on this, and it gets very deep, very fast, way more than what you probably ever want to know. But it says the Q_object macro inside of a private section of the class declaration is used to enable the meta object features such as dynamic properties, signals, and slots. So you need this if you want to do any sort of communication. And the meta object compiler, or mock, supplies each QObject subclass with the necessary code. Let's see that. So here's the folder. I have my code in. We're going to build, and you'll see another folder pop up here. So I'm just going to give that a good build, assuming I don't have any little gremlins lurking. All right, so we got to build. We go back out here. Now here's our build folder. And we've talked about this in a little bit. So here is our binary. On Windows, you're going to see a .exe. And then we have this autogem. Let's go in here and look. See, here's our mock code right here. If we crack this open, doesn't really seem super helpful, but you can see how we've got this test CPP. So we're including this file here, or I should say this directory, this file. So this is an auto-generated thing. Pretty cool, actually. All of that is in here, and then there's this guy. And here's the code that it generated. And this is what mock created for us. And this is basically saying, take our class name, test, and then do any connections for signals and slots and things of that nature in the background here. Also, it provides a lot more information. So you have to remember, a lot of Qt was built before a lot of technology that exists today was even thought of. Qt was just that ahead of the curve. And Qt does things like their own meta information or their own typing system. So, for example, you can get runtime type information support through the C++ compiler. This also goes through the inheritance tree and the Qt property system. A lot of this is way more advanced than what we're going to talk about in this course because you do get into high-end things, but basically you can have a property system that uses signals and slots. So for example, you could say change somebody's age from 21 to 22, and all of these events fire off automatically in the background. It gets extremely powerful once you really master this, but it all starts with the humble QObject macro. All right, so that in a nutshell is the foundational cornerstone of this. And yes, we are simply just hitting the tip of the iceberg on this. It's way more than we could cover in one single video. And the meta object system itself is extremely complex. But under the hood, we don't have to even think about it. It just happens. If you're really curious, there's also this extra information. I always go down to the see also, and it's just how far down the rabbit hole do you want to go? You can read about signals and slots and talk about, how objects interconnect, which we're going to touch on. You can look at the Q meta object itself. And whenever you hear the term meta, think data or additional data. In this case, it's data about data. We're literally defining what things are and how they work. Now, a lot of this, especially if you're new to C++, is just going to look like complete gibberish. But at its heart, when we talk about mock, we're talking about the meta object system. And in Qt, it's responsible for signals and slots in inner object communication mechanism, along with runtime type information and the Qt property system. All of that makes Qt stand out from pretty much anything else out there. Yes, there are some other libraries and frameworks that do similar things, just not as well as Qt does them. All you really need to focus on from a beginner's perspective is include QObject, inherit QObject, make sure you have this macro, and then add signals and slots as needed. You may have noticed we have this signals section here, but we don't have a slots. We can do something like this, and then start adding our slots in there. And you can make public slots and private slots. We're going to talk about all that later, but I wanted to really touch on that just in case there's any confusion. This video, we're going to practice what we've learned so far, and we're going to make an age calculator, but we're going to wrap it in a class, and we're going to do some encapsulation, something we really haven't touched on a whole lot. I may go really fast in some spots and really slow in others just to kind of highlight what I'm doing. So we're going to make a class. I'm going to call this age calc. Now, one of the things you're going to ask is, does this really need to be a QObject at this point? No, it really doesn't, but I'm going to do it just because I want to. It really doesn't add a whole lot of overhead to make something a QObject. Now, let's say age calc, H and age calc, CPP, add those into our project, save, and then it will configure and scan. And then, of course, we have our beautiful header and implementation file here. So I'm going to flip over to the header here, and there's some things I want to do right off the bat. I'm going to add a private section. We haven't really talked about the private section a whole lot. You can either define it manually, or you can do it up here, because up here is, well, private. If you haven't defined what it is, it's just private by default. So up here is private. I personally tend to put the private stuff at the very bottom. It doesn't really matter which way you do it, just whatever works for you, to be brutally honest. And this is where we get into like coding standards and conventions and things like that. So I'm going to say int m underscore age. And you may be asking, why m underscore? We're saying this is a member variable, or it is a member of this class. So a typical naming convention that I use is m underscore. Use whatever works for you. Doesn't have to be named anything. Well, you actually have to give it a name, but you know what I mean. You don't have to follow some specific standard. I'm going to say qstring, and then again, m name. Once again, use what works for you. Now, a lot of times, you're going to hear people say, well, we need to encapsulate things into getters and setters, and you're often scratching your head trying to figure out what they're talking about. Look at this very simple class so far. Private. Our variables are in the private section, so they're not available to the outside world. Let's go ahead and test that. I'm going to go into main, and I'm going to include Qdebug. Don't really need it. It's already included by Qt core application, but just in case something changes in the future. And I'm going to make the age calc. And we'll call this calc. Now, if I say calc dot, we get all the QObject stuff. Remember, we did m underscore, nothing's appearing. Notice how it's just saying there's no member. What? All right, so I'm going to actually copy this. Go here. I know that's an int, so I'm going to just initialize that. Notice now it says is a private member. We're trying to access that from the outside world. If it's declared private, it can only be modified from inside the class, not from the outside world. Only public can be modified from the outside world. So we want to do something called encapsulation. So I'm going to right-click on this variable, refactor, and we're going to create getter and setter member functions. That looks extremely scary, but all we're doing is we're allowing the outside world to set and get that variable in a member function. A member function is just a function inside of a class, basically. And ta-da, it adds the int age function and void set age. This is the standard naming convention that Qt uses. This really is not abundantly important. You can name these however you want, but if you want to use some level of Qt property system or even automation in the future, stay with their standard naming convention. Going to do the same thing for name, just right-click, refactor, create getter and setter, and it does the same thing. We can switch over to the source here, and on the implementation, you can see it does this. So why do you want to do this? What's the point of this? Well, this is called encapsulation. So for example, if I did not want them to be able to set the age, only read it, I could get rid of this set age and also in the header file. And then they could only read it, but we still have a variable that we can use. Also, this is private, this m underscore age. It is a private member variable. I don't want the outside world modifying it directly. I want them to use this function. We get a value or a copy, and we can do what we want. We can validate it, check it, sanity test it, make sure that it's above 0, anything that we really want to do. So by default, I'm just going to leave these blank, but you could put any sort of logic. I'm going to put logic here. So if you wanted to make sure it was greater than 0 or less than 100, you know, for example, like age greater than 0 or something like that, this is where you would do it. All right, now that we've got that squared away, let's jump back here, and we're going to make a couple extra little functions here. I'm going to say int dog years. And let's grab these. And in case you're wondering why I'm using the const keyword, you really don't. It just says that it is now a constant function. Again, there's more technical explanations of that, but from a very high level beginner perspective, just take a huge leap of faith here. I hate saying that because I like to explain every little thing, but we'll have a long conversation. All right, so we're going to right click dog ears, go to refactor, and then add definition. And then cat ears. And then we're going to add definition. And then human ears. Now, once in a while, you'll get this and it won't pop up like it is there now, but it will just say rename symbol under cursor and it won't have this stuff. That just means the IDE hasn't really caught up with what you're doing, and you can definitely feel free to type this in manually. However, using the IDE is vastly faster. So dog ears. I think dog ears is by 7. Turn m age times 7. Now you may be wondering if you need this keyword, if you need to do something like this. You'll actually see people do this, and I've done this myself. You do not, because by default it's already going to be in the current object, which is what this represents. So I'm just going to make some numbers up. I think cat ears is by 9. And then human years, really we could just return mage without any modification whatsoever. Don't even really need that, but just for the sake of completeness, we can go dog years, cat years, human years. Now, in case you're wondering, like if you highlight const and you hit F1, you're going to get absolutely nothing from Qt because it's not part of Qt. I wanted to highlight that. That's part of C++. So if I do int, well, see, now it's trying to find it, but it can't because it's just simply not part of Qt. However, if I do qstring, it should open the help file right up. That's how you tell if it's something part of standard C++ or if it's part of Qt itself. All right, now that we've got our beautiful little class here, we can test this thing out. I'm going to go in here, and I want to make a couple different ages, or a couple different age calculators. So I'm going to say Brian. Wow, can't even spell my own name. It's the kind of day I've had. You ever have one of those days where like your brain and your fingers just are not working? So I've got two of them here. And I'm going to say Brian dot, and I want to set age 46, and Tammy dot set age. Let's say Tammy's 27. Now I want to print this out. I want to print out the human years, the dog years, and the cat years. And I could do that right here, but it would be easier if I just do it in a function. That way I have code reuse. So I'm going to say void print. And then let's go age calc. We have some decisions here. We have to hand that object, because it's a Q object, in a manner in which it's not going to be copied. So we can either work with a pointer or we can pass it by reference. I'm going to do by reference. Actually, let's just call that calc. And then I'm going to say Q info. Let's do calc. And we haven't done the name yet down here. We should probably do that. So we're going to do set name, do Brian. And then let's go ahead and do the Tammy. Set name, do Tammy. There we go. Now you may be curious, what is the difference between the set name and if we go into, let's say, Tammy, and we do a set object name? Well, that's baked right into QObject, where our name is baked into our age calc class. Which one should you use? Well, personal taste. Depends on what you want to do and how you want to do it. Personally, I don't use the set object name unless I really want to bake myself right into Qt. All right, so we're going to get the name, and we're going to say human years. And let's just return that out. And then we can just very easily, through copy and paste, do dog years and then cat years. So the major takeaways here is we can very quickly and very easily make a Q object. We can add getters and setters using the IDE very, very rapidly. We talked briefly about public versus private and how public is available to the outside world, private is not, and you may want to encapsulate things based off whatever logic you want. Typically, you want to use encapsulation, i.e. getters and setters, because you don't want the outside world to modify this directly without you being aware. Then, when we go in here, we want to be able to use these objects in other functions, and we have to avoid copying it. So in this case, we're going to do a by reference. Save run. And let's see this in action. And would probably help if, yes, I actually used the function. How embarrassing. All right, there we go. Minor problem. All right, so now I'm going to actually use Brian, and then let's use Tammy. That's what I mean by it doesn't matter how many years of experience you have, you will always screw something up. There we go. Now it actually works. So Brian would be, wow, a very old dog or an ancient cat, and Tammy would be a much younger person, dog, and a cat. Works as expected.